sigma, then we can form a lambda function with sigma as an argument and t as a body of type sigma to tau. So this is basically saying if t with the new variable type sigma in is of type tau, we can form a function with t being the body. Right. Now, in Haskell, we'll probably proceed now to write a function of the type syntax to maybe type or something like this. So maybe representing the fact that it might not type check, right? In Agda, we can do much better. So the problem with this, I mean, there is no particular problem with this. You can go along with this and you can write a compiler and do awesome stuff. But if we have these facilities that Agda gives you, you can actually return something that not only returns the type disconnected from the input. You can actually return a structure that represents both the structure of the term and the type information at the same time. So you can bring this information around and do stuff with it. So if we get to the optimization part, we can use the fact that the terms have types to kind of embed them into Agda and do stuff like this. So what we're going to do now is define a data type that expresses this. So a term with a type attached. And to do this, we're going to define, I need to define what contexts are first. So I've used gamma here, and I know I'm using indices for variables, and we have vectors. So a good idea would be to simply have vectors for contexts. So not only, we have a list in which we can index into, but we also have the length information, so we can have that extra safety that we'll need later. So I'll simply define context to be a vector of types. I can type this explicitly.